some traditional test instrumentation. Now, the instrumentation we saw in the last video, where we were transitioning from the simulation to the real world, that's what we call virtual instrumentation. So you have a real hardware device that's wired up to a real circuit, but it's connected to a computer, and all the information is fed to you through a computer monitor. So we call it virtual instrumentation. The instruments are virtual, whereas these are physical instruments that exist in the real world, and you can see them, you can interact with them physically. But they accomplish the same things. Now, these guys are a little bit more dangerous than the MIDAC module. The MIDAC module, as I mentioned, is limited in the amount of current and voltage that it can produce. Now, more expensive commercial and industrial data acquisition units can obviously generate a lot more voltage and current and measure greater voltages and currents. But this is the kind of stuff that my students would transition to after using the MIDAC. So we've got a power supply here. This guy is capable of generating 30 volts. You can see it's at 29 volts right now. And the amount of current it can produce is probably in the neighborhood of about 3 amperes. So the MIDAC can produce about 3 milliamps at the top end out of its function generator. The DC power supply out of it can produce about 15 milliamps. So you can consider, if the function generator of that thing is putting out 3 milliamps, this source is giving you 3 amps. I mean, that's 1,000 times more current. This is the proto board that we were using earlier. You probably can't see it very well in the video, but there's a resistor on there, which is the one that I burnt up for the opening post on the website. And so that was pumping maybe 1 or 2 amperes through that resistor, and we fried it. And that's a very easy thing for students to do. If they don't set the current limit on their power supply and they hook up the wrong resistor or hook up the circuit incorrectly, they can easily fry a resistor or a transistor or any other component in the exact same manner that we did in that opening video. But you can see as well, we've got a digital multimeter here. This is an older unit, but I'm doing this at the 11th hour, so I'm doing this out of my home instead of out of my my high-end, high-tech lab at work. And this is a real oscilloscope. So this is what the real oscilloscope looks like, or the physical oscilloscope, I should say, because the one from the MIDAC is real. It's virtual. It's hosted through the computer. But the thing is, when you start using these real instruments and have a power source that can generate, like I said, 3 amps at 30 volts, you can set things on fire. So students can blow fuses on their meters. That's kind of the best thing that you can hope for in the case of doing something wrong. Or they can damage the instrument. I've seen the front ends out of oscilloscopes blown out. I've seen all kinds of interesting and unfortunate things. Capacitors can explode, so we have to wear safety glasses. Electricity is really, really dangerous. I remember a teacher of mine going way back who said something to the effect of, the only electrician that's not afraid of electricity is a dead electrician. Electricity is very, very dangerous, and students are scared of it, especially if they're just getting into electronics or electricity for the first time, and rightly so. Like I said, it's a very, very, very dangerous thing. Even at what appear to be low voltages and low currents, you can still do damage. So it's great that they can practice their skills on a simulation first, transfer those skills up into something that are there's some risk mitigation there. And then eventually get into the stuff where you can actually catch stuff on fire, which usually you do by accident, and occasionally on purpose, but usually by accident. Usually. Thanks.